Hello and welcome back to our revision in DT, our 12 days of DT exam revision for our GCSE students. Let's get started. Okay, so on our 5th day of DT, our DT teacher sent to me 5 physical material properties. Now, I would say that probably of all the DT revision, the biggest thing you need to be able to remember are your material properties and your physical properties of your materials. So there's a little sneaky peek into maybe what's happening tomorrow. But certainly from today's point of view, we're looking at physical material properties, and we've got 5 of them to go through. And you're probably thinking, yeah, but sir, you've only got 3 on the board there. So, well, yeah, I've got another slide. You know, I've had to squeeze them in so you can see them properly. So, let's go through. I've got my pointer with me. No, I haven't. So let's get my pointer. Ha! There we go. So let's go through these then. Absorbency. Excuse me. The ability of a material to take in or soak up liquids, but sometimes they can be. You could absorb light or even heat. Natural fibres, papers, and boards are usually good absorbers. So when you think of things absorbents, things that spring to mind are things like nappies and diapers, depending on where you're coming from. And of course, their goal is to absorb liquid and to make sure that it doesn't cause irritation, things like that. From a product design point of view, that's pretty much the main goal of those, isn't it? So if you're thinking about designing nappies or diapers for babies, then your main goal is to make sure that they have a strong absorbency. And of course, there are other products as well around the world that would need to be good at absorbing liquids to stop things from going wrong, perhaps. Maybe you've got something that needs to protect against liquid, so it needs to have a good absorbency. Next one, density. Students sometimes get this one mixed up with just thinking things are thick. Thickness doesn't really have much to do with that, really. It's literally specifically the material's mass per unit of volume, which essentially means, if you look at my picture of these woods here, we've got all these trees and they're all densely packed together. So yes, we could think about things being squashed, maybe, and things being thicker, but thicker means we're going that way, and really, if you're dense, it's going this way, so it's more compact. I would argue there. Yeah, so density of how things are. So of course, looking at those trees, I know it's not a material, but if we looked at that and thought, well, if I'm going to throw something in there, it's like a ball or something, it's going to bounce back at me because they're so dense. So it's quite good at protecting things if things are dense. And if they were spread out and they were less dense, then you could put things through them and stuff. So it's a way in which you can have a product having a strong density. It would make it more sturdy, more stable, I suppose. But products with density, like MDF, for example, medium density fiberboard, the fibres are so dense, they're so closely put together that it makes the material hold its shape. Which is fantastic for us when we're making things in large sheets, for example, but I'm going off on a tangent there. Fusibility, one that I don't really use very often in my specialism, but it's certainly one that is certainly important to people who do electronics. It's the ability to a product to be converted into molten or liquid through heat, which often refers to things like soldering. So if you imagine soldering iron, and we're going to attach 2 pieces of metal together and essentially fuse them together is the correct way. Glue is not the right way of describing solder. A lot of students, for some reason, decide to say, "Oh, I'm gluing metal together." Well, no, you're not. You're not gluing it. You're fusing it. You're making it a molten state first of all, and then you're allowing that to join together, which would be fused, as opposed to having glue attached to those. So fusibility, the product to be able to conduct things, convert, not conduct, that's my next thing, to convert metals into liquid and put them. So what kind of things do you want me to do with this? Same thing we did with yesterday with the revision cards. Have a card on absorbency on one side, and then on the flip side, maybe a diagram, and then the description, maybe bullet pointed. I've tried to keep this as brief as possible, but sometimes I just have to explain what it is, and it needs a little bit more to it. So put it into a fashion that would make sense to you. Sometimes I tell my students to describe something like fusibility in 10 words or less, just picking out the key terms so it helps you remember them. And but definitely use those as flip cards. So then turn the card over, have a look, fusibility, can you reel off and tell me exactly what that is? Next one. Excuse me. Electrical conductivity, the ability of a material or product to conduct electricity. Now usually, of course, metals are the best things for conducting electricity, whereas plastics tend not to be. Now here's a little chap on the back of this bus. He is what we call the bus conductor. He will check your tickets and make sure that you've paid to come on. Now the reason I've shown you this is because how I describe this to students is the conductor allows things to happen. So if something's conductive, it's allowing it to happen. So if this chap here is my electrical conductor, he's allowing electricity to come on board and flow through that bus. If he's a thermal conductor, he's allowing heat to come onto the bus, which moves us on to our next one, which is thermal conductivity. So thermal, closely linked to the word thermometer, which measures heat and temperature. Don't get these two things confused. Electrical, of course, works with electricity, and thermal deals primarily with heat. So it's the ability of a product to conduct heat. Metals, again, are very good at this and tend to be good thermal conductors, allowing that heat to come on. Whereas plastics and timbers are poor conductors, which makes them by default, I suppose, excellent insulators. Now we need to be understanding the two differences between conducting and insulating. So let's have a look at these wires up here. We've got 3 copper wires, all wrapped in a plastic or rubber. Well, what's the word for that? I can't remember what it's called. Mine's gone just dumped. Anyway, so it's coated in with plastic. So we've got the electricity flowing through here. We've got the plastic or the rubber, which stops the electricity from touching, because I don't want these two things to touch each other, because one's live and one's earth, and I don't want those to touch each other, otherwise I'm going to go bang. And then of course that's all wrapped in again another either plastic piping or possibly rubber again, to make sure that what's flowing through these isn't flowing through this. When I pick this up with my hand, I don't want to get electric shock, so I need insulators with my conductors as well. Think about radiators from a thermal conductivity point of view, and well, of course they tend to be metal, don't they? I don't think I've ever seen a plastic radiator. It doesn't really work or last very long. So the reason why we have thermal conductors, allowing that heat to come through, whether it's water or whatever it is, that water usually pipes through these radiators and heats them up. The metal then gets hot and then heats your house up, or heats the home or the school. So there you go, there are conductors and our insulators. So insulators being plastic. Think of a screwdriver, and you often have a metal end, which tends to be nowadays magnetic, so you can actually screw things in, like your plug sockets, and attach them to the wall with a screwdriver. Whereas the handle tends to be plastic, or again rubber, which is an insulator, because I do not want to get a shock when I'm doing some electrical work or anything like that. So if I'm soldering a circuit or anything, I don't want my hand to get a shock through it. So there you go. So there are 5 products. Let's head back to home base and finish off for today. So what have we learnt in today's session? We've come across our DT teacher has given us, or sent to us, 5 physical material properties. These 5 material properties are very important. You need to be able to understand them. They're going to come up in your exam in one form or another. So again, 5 cards: electrical conductivity, thermal conductivity. We could flip back to the other 3 as well and talk about absorbency, density and fusibility. And again, I do a little drawing maybe to remind me or prompt me to remember what I've said, highlight keywords, and then make yourself a little revision resource. Bit of a longer video today, but it's needed because, again, very important material properties, and I can't wait for tomorrow's episode where we're going to continue our properties, but this time looking at something a little bit more interesting. Well, I say more interesting, it always gets more interesting. Anyway, until next time, stay safe. Bye now.